Workbook page 31, finishing up our lesson on slope. If you look at number 1, once again, they have this triangle underneath, which is not how we're doing these, because slope we're looking at as a change in y over change in x. We want to look at our y first and then our x. So, not a big fan of that triangle. Also, the point they've directed us to, that second point, is kind of an in-between point anyway, so it's really not our best choice of point to use for finding our slope. Remember, for finding the slope here, we need to find 2 points on the line and then figure out what our change in y and change in x are. So one point they have kind of directed us to here, if you look, it would be the point 520. Another point that this line goes through is the point 0, 0. If you wanted to, right at the end here of the graph, it does go through the point 1040, but the 0, 0 and the 520 we picked, those are smaller numbers to work with. Probably be a little bit easier for us to work with those numbers. So if we start at 0, 0 going to 520, we're going to look at our change in y and our change in x. So when you guys do these, if you want to color code, if you want to use colored pencils and stuff to color code to keep track of what you're doing here, change in y, our y value went from 0 to 20, which means our change in y is 20. If you want to show work on that at all, remember, finding the change in something, you subtract. So you could say, we could do 20 minus 0, which is 20. And then we'll look at our change in x. So our x is going from 0 to 5. So our change in x, we could take 5 minus 0, which is 5. And at that point we have 20 over 5, which means 20 divided by 5, which is 4. So our slope would be 4. So if you were filling in the blanks here, if you wanted to specifically fill in the blanks they gave you, you could just do those last parts that we did. But understand that, you know, this part up here of showing the work of what you're doing is probably not a bad idea also. Always think about as well, like we talked about previously, that whether your slope's supposed to be positive or negative. Looking at this line with what we've talked about, this should be a positive slope, and that's what we got, so we should be in good shape here. If we look at number 2, they want us to find the slope of the line, use the 2 points shown. What's different on this problem is that this line is not going through 0, 0. So not going through 0, 0, we might have a little bit more of a thought process in order to figure out what our change in y and change in x are. So once again, change in y, if you want to, we can look at our y values. So when we're doing these, I like to start with the point further to the left, which in this case is -1, -5, and think about how do I get from there to the point 2, 1. So y values, we went from -5 to 1 in that case. So a couple options you have to find that change in y. One option is to subtract. And subtracting, I would actually start, if you wanted to, you could do this as 1 minus -5. 1 minus -5, and then you can add the opposite there, which is like 1 plus 5, which would be 6. Another way you could do this would be to draw a number line and think about how do we get from -5 to 1. How far do we go to get from -5 to 1? And then you could say, well, to get from -5 to 0 would be 5, and then from 0 to 1 is 1, so that's all together would be 6. Same idea for the change in x. X values, we're going from -1 to 2. So to do that, we could do 2 minus -1. Again, you can add the opposite there, and that will be 3. Or you could think about on a number line, how do we get from -1 to 2? -1 to 0 is 1, 0 to 2 is 2, 1 plus 2 is 3. So we went up 6 and over 3, and 6 divided by 3 is 2. Our slope is 2. It looks like a positive slope from the graph, so that's a good sign there. So 2 would be our final answer for this problem. If you wanted to fill in the blanks here, it would be basically what we just did up here, showing our work. If we look at number 3, it is different because there is no graph given. Technically, you could use graph paper and graph these points and then find the slope. What I'm going to do is just kind of sketch a graph out. Technically, you can do it without even sketching a graph out, but it's kind of nice sketching a graph at least to maybe see whether your slope's going to be positive or negative, if nothing else. So if we start out, if we're at 0, 10 would be on the y-axis, and then 24, 6. Well, my y value went from 10 to 6, so did we go up or down? We went down a little bit. So 24, 6 would be over here somewhere. So just sketching the graph then, we can see that this looks like it should be a negative slope. Once again, finding the slope, it's change in y over change in x. So again, we can look at our y values here and think about what we're doing. So if we go from 10 to 6, that's going down by 4, so change in y is going to be a -4. If you wanted to work something out with that, you could do 6 minus 10. 6 minus 10, and then if you add the opposite there, 6 plus -10 is -4. And then change in x. So our x values go from 0 to 24. So if you wanted to, you could say 24 minus 0, which is 24. And then the only thing left is that we can reduce these both by 4. And so the slope is -1/6. It is negative slope like we were anticipating. One thing about this, when you guys do this, if you show your work like we did here, you have to just make sure you're consistent. So in other words, if I start with the 6 for the y's when I'm subtracting, I have to start with the 24 for the x's when I'm subtracting. If you do one starting with one point, do the other one starting with the other point, what's going to happen is you'll get the wrong sign for your slope. In other words, we would get 1/6 instead of -1/6 here. And it's not to say that you have to do it the way that we did it. If I was working this out by hand and I wasn't sketching a picture, what I like to do is try to avoid negatives a little bit if I can. So usually what I try to do is start with the bigger y value. In other words, I have an option when I'm doing a change in y. I could either do 10 minus 6 or 6 minus 10. Well, 10 minus 6 is going to give me a positive number there at least. And then the deal is, though, if in that case, if I started with the 10 for the y, I have to start with the 0 for the x. I have to start from the same point. So in that case, for the x's, we would do 0 minus 24. So 10 minus 6 is 4. 10 minus 24, if you add the opposite, that would be a -24. And then reduce And you might say, well, that's 1 over negative 6. We got negative 1 over 6 the other way. The negative's just in a different spot. It's still the same thing. Those are still the same. Normally with a negative fraction, they put the negative up with the numerator. So you've got a few different options on how to do that. Just showing you your options there, so you've got a choice of what to do when you work that one out. One other option you guys have, a final option, would be just to graph the points using graph paper. 24 is a little bit big of a number there, but technically you could graph that going by ones even, and then you could count your squares and say I went down this many squares, I went over this many squares, and you could figure your slope out that way as well. Obviously it doesn't become very convenient when your numbers are like hundreds or thousands or stuff like that. You're not going to want to go by hundreds or thousands going by ones. You'd want to change your scale, you know, going by 50s or hundreds or something maybe. But, you know, so some cases it might be in your best interest to actually learn this of how to work these out by hand as well. Number 5, the graph shows the number of centimeters a particular plant grows over time. What is the slope of the line? So first thing, before I even work this out, I might just think about if this is going to be a positive or negative slope. So this is going to be a positive slope when we work this out. Now we need to find a couple points. So one point that this line goes through is right here, hits exactly, and if we kind of look at what's happening there, that would be the point 2, 3. So another point that this line goes through is the point 5, 6, right at the edge of the graph. It does go through 0, 0, but just to make things interesting, we're going to use these 2 points because it doesn't always go through 0, 0. So
would that not be 4, 6 instead of 5?
All right, and this actually, thanks to some students for catching my mistake here, this would be the point 4, 6. The x-axis we're actually going by halves, so that would actually be 4, 6, not 5, 6. Alright, so if we look at our change in y, looking at our y values here, we went from 3 to 6. So that would be 3. If we were wanting to show work on this, which is probably a good idea, we could do 6 minus 3. And the change in x, we went from 2 to 4. Okay, so our change in y was 3. Change in x, since we went from 2 to 4, that's changing by 2. And again, to show that, we could do 4 minus 2, which is 2. One thing you have to watch for here is that since they're going by halves, it's not just counting the squares. There are 4 squares here going by halves. 4 halves gives you 2, so that's something we got to be careful about. And then this one is probably a good idea to go ahead and change this over to a mixed number or to a decimal. So that would be 1.5 or 1.5. That would be our slope. And then that's for part A. For part B, what does the slope mean? So for this particular problem, what does it mean if our slope is 1.5 or 1.5? So this would tell us that the plant is growing 1.5 centimeters per week. And the way we know that is our y was centimeters divided by our x was weeks. So centimeters divided by weeks gives us centimeters per week. Number 6, a machinist measures the thickness of a grinding pad every week. The graph shows how many millimeters the grinding pad has worn down. What is the slope of the line, and what does the slope mean? So once again, looking at this, first of all, positive or negative slope? Positive, okay. And now before we can find our slope, we need to find a couple of points on our graph. So one point that this line goes through is right here, which would be 415. Another point that this goes through is the point 0, 0. You could also use, they've got kind of marked off there, the point 830 looks like. Those would be basically the three that we'd want to potentially look at. So finding the slope, we're going to find the change in y over change in x. So change in y, our y value, we went from 0 to 15. So our change in y, if you wanted to, you could do 15 minus 0, which is going to be 15. And the change in x, x's we went from 0 to 4. So that's a change of 4. If you wanted to, you could do 4 minus 0, which is 4. Once again, probably makes sense to change this to a mixed number or to a decimal. So this would be 3 3/4 or 3.75. So that would be the answer to the first part about what our slope is. And then the second part, they want us to tell what the slope means for this problem. So one way of looking at this, we could say the thickness lost is 3.75 millimeters per week. Basically, that's telling us the pad is wearing down by 3.75 millimeters every week. Initially, before we looked at the graph, you might have been, I know I was kind of expecting to see a negative slope because thinking about the thickness of this grinding pad would be going down, but they're talking about what thickness is lost over time. So that's why this is actually being shown as a positive slope. So this gives you an idea of how to work with proportional relationships in slope.